Now we're gonna learn how to multiply surds. Well, in multiplying, it is not necessary for the square root to have a same number so that the operation is done. For example, here we can see 3 to the 12 times square root of 6. That is totally multipliable. For example, it gives us 3 to the 72, then 3 to the 9 to the 8. The square root of 9 is 3, so it would be 3 times 3, 8. Then we get 9. Now let's do this little thing over here. We get 3, no, sorry. We get 9 to the square root of 8. That makes 9 to the square root of 4 and square root of 2. So 9 times 2, square root of 2, that would be 18 to the square root of 2.
Firstly, for adding and subtracting radicals, it is important to know that the number inside the square root is called a radiant. There are some rules you need to follow so you can add and subtract radicals. Firstly, the simplest addition or subtraction in radicals is like this. It's a very simple problem. You can see that both radians are the same. So by this, you can add the both numbers outside the square root. That would be 5. Square root 3. If the numbers are not the same inside the square root, the radians are not the same, like in here, 9 plus 25. What you need to do is to
Another important point is to understand that the numbers outside the square root will be multiplied by the other numbers outside the square root. For example, these two numbers get multiplied and these two numbers get multiplied. That would give us 18 to 20. Then and the final answer will be this. It is a drastic, it is very important to understand that they are never multiplied, the numbers outside the square root will be never multiplied by the numbers inside the square root. And the numbers inside the square root will be never multiplied by the numbers outside the square root. Well, now for simplifying, to understand how to simplify is very important for the operation of this type. Well, for the process. For example, in 8 to the 2 times 3 to the square root of 12, well, that will give us 24 to the square root of 24. As we multiply 8, that is the number outside, and 3, that is the number outside as well, it gives 24, and 2, that is number inside, and 12, that is another number inside, gives 24. Now, this is the operation that is very important. All right, let's erase this. Erase this. And, for example, we get the square root of 24 by multiplying the square root of 4 and the square root of 6. Now, it is important to take into account that the square root of 4 equals 2. And taking into account the square root of 6 is not simplifiable, so we get an answer as this. We multiply, wait a minute, we multiply 24 times 2, as 2 is the square root of 4, and as 6 is the square root of 6 is multipliable, we get 26. Now, the answer is 48 and the square root of 6. That's the answer. Now we're going to learn how to divide surds. Now, for example, for dividing surds, the numbers inside the square root do not have to be the same as well as in dividing. For example, this example, we're going to place 6 to the square root of 27. Now, we use the method of simplifying, so we get the square root of 27, that is, that we get it, then the square root of 9 and the square root of 3. And as the square root of 9 is 3, so we get something like this. Now, it would be something like this. The square root of 6 and the square root of 27. Oh, sorry, 27, no. The square root of 3. Square root of 3 to the square root of 3. Now, we divide 6 into 3. We do a normal division with the two numbers inside the square root. And so we get square root of 2 to the 3.
A lot of people use sorts in real life. An example of this is engineers. During their career and when they are packaging engineers, like this one, the one I'm going to draw here. This is a boat. When boats are bringing shipments like from another country, they contact packaging engineers. These engineers are contacted to make a palette of specification of the shipment. So let's say you have you have 1 box, 2 box, and they bring goods inside of them. The engineers are contact to make any specifications of them, and let's say a brand of containers, Hamburg Süd. They are contacted by Hamburg Süd to give all the specifications of the packages and what they bring inside. This work of the engineers is good for the companies because they can optimize the number of goods they can bring inside a box. So let's say they can optimize the volume of each good. So I'm going to make a brief drawing of a box. Let's say this, and this is the container or the box, and they optimize the volume of the goods they can bring inside. This is the work of an engineering of packaging. Engineers also use sorts in real life when they want to get a very precise value. So let's say they were making a bridge like this one I'm showing you right now. So they came across a sort, but they say, oh no, this is too long, so we're gonna just get a messy decimal, let's say. So this will say that the answer will not be precise, and they're risking the life of the workers and the life of the people that are going to use the bridge after it is done. So this is why sorts are very precise in real life, and they can make a construction that it needs a lot of engineering, very precise, and will bring safety to humans.